Hello, this is Christopher, and I'm going to talk about Bepp 250, behavior economics and public policy, and the consumer theory portion of it. So, within the consumer theory portion, the main equations are these. The marginal rate of substitution is the most important concept in the entire lecture, and this is the connection to everything we learn about. So, the marginal utility of the two products, for example, product A and product B, equals, divided against each other, equals MRS, the marginal rate of substitution. And then that is also the ratio between the prices, as well as the slope for the budget's constraint line. And then we look at the budget constraint line. The budget constraint line is PA times, so the price of A times the amount of A plus the price of B times the amount of B equals the constraints, or the limits of how much they can make. This is a pretty obvious, simple concept intuitive to understand. How much it costs times how many you buy. For example, if I only buy apples and oranges, and apples are $3 and oranges are $5, then I buy 10 oranges 10 times $5, then apple is $3 and I buy 5 apples. So that's a very simple, easy to understand concept. But in this case, price of something doesn't necessarily have to be like the price of an object. The price can be, for example, if you're working and then you take a break, 1 hour of rest. This 1 hour of rest, the price of an hour of rest is how much you could have made the hour of working. So if you could have made $10 an hour of working, the price of rest is $10, which is an idea in economics that you not only lose what you're also losing what you're not making. And on the same note, Y can be hours, or 24 hours in a day, not just price. And effective income is another way to understand the macro understanding of, if a graph, if it will go down or if it will go up, and if an increase in income will affect it a lot. We can use this equation to calculate it. So now we have our example. This example is Robinson Crusoe salvaging for scavenging for coconuts and fish. So the utility, if he had his utility function, which is how you can see it as how happy he is, that function is the amount of coconuts to the 1/3 power, and the amount of fish to the 2/3 power. And we utilize this equation to calculate his utility. But what his marginal utility is, and this is the first thing you should probably do. They'll give you this kind of equation, and the first thing you should probably do is look at the marginal utility. The marginal utility is basically the derivative of each portion of this, the derivative of each portion of this equation. So we first derive C, and then each variable in the equation. We first derive C, and the marginal utility of coconuts is 1/3 times C to the negative 2/3 times F to the 2/3. And then the marginal utility of F equals C to the 1/3 times F to the negative 1/3 times 2/3 in general. So now I have the marginal utility, and this was basically just calculated through pure calculus, deriving it. Now we have a chance to understand the marginal rate of substitution. The marginal rate of substitution is how much is one thing worth compared to the other. So how much is a fish worth to a coconut? Especially in utility. So marginal rate of substitution, we can calculate from this is F divided by 2C. Because marginal rate of substitution is basically the first product divided by the second product. And if we calculate this, it's 1/3 times, so let's do the calculations here. I'll use the green pen. 1/3 and 2/3, we can cancel this out because it's, no, we can cancel this out and put 1/2 here because 1/3 is clearly 1/2 of 2/3, so we can do like 1/2. And then c to the 1/3 on the bottom of the line is equal to c to the negative 1/3 on the top of the line. So if we put c to negative 2/3 plus c to the negative 1/3, we have c to the negative first. It's just c to the negative first, which is just brings it down. So we can put c on the bottom, and then this is more intuitive. This is a negative below. So if it's a negative below, it's actually positive. It's a double negative, it's positive. So it's actually a positive one, f to 1/3. So f to 2/3 plus f to 1/3 equals f. So on top there's f, on the bottom there's c, and then if we evaluate it, it's f divided by 2c, which is right here. Now, marginal rate substitution also has the meaning of the price ratio. It also has the slope of the budget constraint, but it also means the price ratio. And the price ratio is also used to calculate PC divided by PF. And if we put these two equations, because we're given PC equals 1, and the price of coconut is 1, the price of fish is 10. Also, we only have a constraint of 120. But 1 divided by 10 is equal to this f divided by 2c. And if we put these two together, and we look at this part right here, we see that 2c equals 10f, that means c equals 5f. So the marginal utility of a coconut is that of 5 fishes. So now we have c equals 5f as an equation. So we can use that to replace it on the bottom later. Now let's look at budget constraint. So the budget constraint is just how much in general can this person actually produce without going over that hits his limit. So the budget constraint is PC times C plus PF times fish equals the total amount of money or availability that the dollars amount. So we plug this in, 1 times C plus 10 times F equals equals 120. And then we can just use this graph first to calculate a kind of an idea, like a general graph of what it will look like. So if we look at this part, this is fish and this is coconut. If we take this part out, then 10f equals 120, and it's only going to equal 12 to 120 divided by 10 equals 12. So if we didn't buy any coconuts, we could only buy 12 fishes, and we would put the y-axis at 12. And if we couldn't buy any fishes, we only bought coconuts, we will have 120 coconuts. So this is the other side of the quantity of coconuts. And this is basically the budget constraint line, and it shows what is the slope of how steep of the slope it is. And you realize that the budget constraint line is also equal to 1/10. This slope is negative 1/10. So, which negative and positive doesn't really matter in this situation. in any problems in this sort. So negative 1/10 is going directly downhill. And then this is also matching that, which is a good thing. Then we have our optimal solution is when MRS equals our, when we can plug this in, when we can plug this equation in to here. And that's when our bang for the buck, for, if you will, is equal to the budget constraints. And if we plug this in to this equation, we get 1 times 5f. Oh, so our original equation is, no, so if we plug this in, it's 1 times 5f, 5f replace c equals 5f, so 5f replace c plus 10 times f, which equals the total. And if we calculate that, because we have 15f, then 120 divided by 15 equals 8. So 8 is the amount of fishes we should have. And then 120, and then if we plug that back in, plug that 8 back in, we have 40 coconuts. So we'll have 40 coconuts and 8 fishes. And this is our equation. And this is exactly where our bang for the buck meets our budget constraint. And a bonus question, if, for example, the price of coconuts increases, for example, it increases to $5, what we'll do is we'll change the price of coconut to $5, and we will change coconut. Yes, we'll change the price of coconut here. We'll change that to $5, and 5 times 5f plus this, which is 25, and then you can calculate the rest and do the same graph. And the graph itself would go downwards, and I think this will reach 24. So it will be like here, and this will be the slope. So that's it about consumer theory, and thank you so much.